Hello Java aspirants, this is Gaurav, an expert Java trainer. As per high demand from many people, I am commencing the Java discussion from scratch. Let's keep threads topic on the table today for discussion. What is thread? A thread represents a separate path of execution of a group of statements. If we write a group of statements, then these statements are executed by JVM one by one. Even if you don't create any thread in your program, thread will be running there and main method will start that. Main thread always run in a Java program by default. A thread represents execution of statements. The way the statements are executed is of two types. First is single tasking, another one is multitasking. What is single tasking? A task means doing some calculation, processing, etc. Generally, a task involves execution of a group of statements, for example, executing a program. In single tasking environment, only one task is given to the processor at a time. The processor will complete one task and then starts another task. This means we are wasting a lot of processor time and microprocessor has to sit idle without any job for a long time. This is the drawback in single tasking. Another one is multitasking. To use the processor time in an optimum way, we can give it several jobs at a time. This is called multitasking. But how can we give several jobs at a time? Suppose there are 4 tasks that we want to execute. We load them into the memory first. Then the memory is divided into 4 parts and the jobs are loaded there. Now the microprocessor has to execute them all at a time. The main advantage of multitasking is to use the processor tire in a better way. We are engaging most of the processor time and it is not sitting idle. In this way, we can complete several tasks at a time and thus achieve good performance. Multitasking is of two types. First, processor-based multitasking and another one is thread-based multitasking. In processor-based multitasking, several programs are executed at a time by the microprocessor. In thread-based multitasking, several parts of the same program is executed at a time by the microprocessor. In this figure, here we have a program. In this program, there are two parts. These parts, task A and task B, may represent two separate blocks of codes or two separate methods containing code. Each part may perform a separate task. The processor should execute the two parts, or we can say tasks, simultaneously. So the processor uses two separate threads to execute these two parts. Each thread can be imagined as an individual process that can execute a separate set of statements. We can imagine these threads as hands of the microprocessor. We have two hands, so we can do two things at a time. Similarly, if a processor has two threads, it can do two tasks at a time. This is called thread-based multitasking. Next is uses and priorities of threads. Threads can be used for multiple purposes. Some of the uses of threads are mainly used in server-side program to serve the needs of multiple clients on a network or internet. Threads are also used to create game and animations. What are the priorities? When the threads are created and started, a thread scheduler program in JVM will load them into memory and execute them. The scheduler will allot more JVM time to those threads which are having higher priorities. The priority number of thread will change from 1 to 10. The minimum priority of a thread is 1 and the maximum priority is 10. The normal priority of a thread is 5. Thread creation and running. First, create a class that extends thread class as class myClass extends thread, or implement runnable interface as class myClass implement runnable. Now, in this class, write a run method as public void run. Inside that, some statements. By default, this run method is recognized and executed by a thread. Then, create an object to myClass so that run method is available for execution as myClass th equal new myClass. Then create a thread and attach that thread to the object th. Here, thread t equal new thread th, or we can write thread t equal new thread parameters th thread name. Then run the thread. For this purpose, we should use start method of thread class as t.start. Now you can see the thread will start execution on the object of my class. In that object, run method is found, hence it will execute the statement inside the run method. A thread will terminate automatically when it comes out of the run. To terminate the thread on our own, we need to execute return statements inside the run method. What is the difference between extends thread and implements runnable? Which one is advantageous? Extend thread and implementation runnable both are having same functionality, but when we write extend thread, there is no scope to extend another class as multiple inheritance is not supported in Java. If we write implement runnable, then still there is a scope to extend another class. This is definitely advantageous when the programmer wants to use threads and also wants to access the features of another class. Next is single tasking using a thread. In this, a thread can be executed one task at a time. Suppose there are two tasks and each task having two assignments to be executed. First, we have to create an object to my class thread class, then create a thread T1 and attach it to the object, and then execute the thread T1 on that object's run method. In this way, a single thread T1 is used to execute two tasks one by one as assignment 1 of task 1, assignment 2 of task 1, assignment 1 of task 2 and assignment 2 of task 2. Here if you see, single thread will finish both the assignments of task 1 and then it will start task 2 and finish both the assignments. Here we notice that task 2 is sitting idle till the task 1 assignments are finished. It is a waste of resources and time. So this is all about single tasking. Now next is multitasking using threads. In multitasking, several tasks are executed at a time. Suppose there are two tasks and each task having two assignments to be executed. First, create two objects to represent two assignments, ASG1 and ASG2. Then create two threads and attach them to the two objects. And then start the thread. It will execute as assignment 1 of task 1, then assignment 1 of task 2, then assignment 2 of task 1, then assignment 2 of task 2. Here, both the threads will start assignment 1 of both the task 1 and task 2 parallelly, and then they will execute assignment 2 of both the tasks. Here we notice that both tasks are start execution. No one is sitting idle. It is best way to utilize resources and time. Next is multiple thread acting on a single object. In previous topic, we have two threads and two objects. It is also possible to use two or more threads on a single object. But in this case, sometimes we get unreliable result. Let us see, when two children, we can say threads, perform same task, then they need same object, run method, to be execute each time. Let us think only one ball is there in a field and two children are trying to pick the same ball. We have to run a method in that we have mentioned only one ball is available, and if ball is available then ball will pick by a children, else ball is not available. And then we have two threads which attach to the same object. Thread T1 equal new thread obj, then thread 2 equal new thread obj. After that, run the program to pick the ball as T1.start and T2.start. If we compile and see the output, both children pick the same ball. As mentioned in run method, only one ball is available, then how both children can pick same ball? It means result is unreliable. So what is the solution of this problem? Let us keep second thread T2 should wait till the first thread T1 release the ball after play. Let us not allow any other thread to enter the object till T1 comes out. This means we are preventing the threads to act on the same object simultaneously. This is called thread synchronization or thread safe. What is thread synchronization? When a thread is already acting on an object, preventing any other thread from acting on the same object is called thread synchronization, or we can say thread safe. The object on which the threads are synchronized is called synchronized objects. Thread synchronization is recommended when multiple threads are used on the same object, that is multithreading. There are two ways to synchronize the objects. First is using synchronize block And synchronize block syntax as shown here, synchronize object and inside that statements. Here we can embed a group of statements of the object inside run method. Here object represents the object to be logged or synchronized. The statements inside the synchronized blocks are all available to only one thread at a time. Another one is using synchronized keyword. Using synchronized keyword, we can synchronize an entire method by using synchronized keyword. For example, synchronized void display inside the statements. Now, the statement inside the display methods are not available to more than one thread at a time. This method code is synchronized. What is the difference between synchronized block and synchronized keyword? Synchronized block is used to synchronize a block of statements. Synchronized keyword is useful to synchronize an entire method. Next is deadlock of threads. When a thread has locked an object and waiting for another object to be released by another thread, and the other thread is also waiting for the first thread to release the first object, both the threads will continue waiting forever. This is called thread deadlock. How to avoid thread deadlock? There is no specific solution for this problem of deadlock. It depends on the logic used by the programmer. The programmer should design his program in such a way that it does not form any deadlock. How we can improve the efficiency to communicate between threads? Java.length.object class provides three methods for this purpose. First is notify. This method releases an object and send a notification to a waiting thread that the object is available. Another one is notify all. This method is useful to send notification to all waiting threads at once that the object is available. Another one is wait. This method makes a thread wait for the object till it receives a notification from a notify or notify all method. And it is recommended to use these methods inside a synchronized block. What is the difference between sleep and wait method? Sleep method are used to suspend a thread execution for a specific time. When sleep is executed inside a synchronized block, the object is still under lock. Sleep is used for making a thread to wait for some time. And the wait method is executed, it breaks the synchronized block so that object is removed and it is available. Wait is used in connection with notify and notify all methods in thread communication. Next is thread lifecycle. When we create a new thread object using new operator, thread state is new thread. At this point, thread is not alive. When we call start function on thread object, its state is changed to runnable. A thread in this state is considered to be executing its task. Then the thread enters runnable state, and when sleeps or wait method are used, or when the thread is blocked on input output, then it goes into not runnable state. From not runnable state, the thread come back to runnable state and continue running the statements. The thread dies when it come out of run method. And last is Daemon Thread. What is Daemon Thread? A thread that executes continuously without any interruption. Daemon Threads are service providers for other threads or objects. It generally provides a background processing. For example, oracle.exe is program, or we can say thread, that continuously execute in a computer. When the system is switched on, it also starts running and will terminate only when the system is off. So this is all about threads. Thank you for watching my video. Please keep watching my more videos to learn Java in an easy way. You can send me an email for any query to my email ID, go for elearning@gmail.com. Thank you.